Okay, hi again, everyone. It's time for us to start thinking about bivalence and the law of excluded middle in particular. So, there's a central feature in our systems that we've worked with so far that makes them classical, makes them examples of what we call classical logic, and that's the principle of bivalence. And the principle of bivalence says that each well-formed sentence has, on any interpretation, exactly one of two truth values. Either it has the value true or it has the value false. Okay, so we only allow these two values, and we require that every sentence that we include in our system has exactly one of those values. Now, the pretty outdated picture we've got at the top of the slide here, which comes from a previous era of the US, talks about alternative facts and the idea that there are some things that are kind of ridiculous, that proposing alternative facts is an absurd thing to do. And this might seem like one of those cases where it's worse, right? So it's absurd to suppose that the icebergs are disappearing because polar bears are eating them. It's even more absurd to suggest that some logical principle like this, like the principle of bivalence, could somehow fail to be true. That can seem particularly odd. We need really good reasons for denying that. But we can see later that there will be some reasons for us to actually have doubts. But on this understanding of bivalence, it is definitive of classical logic. And any system that rejects it is going to count as what we call, quite clearly, a non-classical logic. Now, we're going to contrast this a little bit to the law of excluded middle. Okay, it's a really closely related principle, but it's something we want to make a distinction between. Okay, bivalence and the law of excluded middle are not actually identical. So the law of excluded middle says this. It says that it's a theorem, right? It's something we can prove from no assumptions, that P or not P is true for any particular sentence. Okay, so if we think back to where we were looking at natural deduction, what we want to do is to be able to say that this kind of sentence, P or not P, is going to come out true no matter what particular sentence we have. Now, it looks pretty similar to what we've had before. But as I said, this is a theorem. It's something that we can prove from no assumptions. Rather than us speaking about the truth values that we accept, the truth values that we're going to have in our system, or what we're going to allow them to do, instead we just say, we can prove this. Okay, no matter what the circumstances are, we can prove this sentence to be true. Now, bivalence is often described as what's called a semantic principle. It's about how we interpret what our logical languages mean. And the law of excluded middle as a syntactic principle, which is about what things we're allowed to infer. Okay, instead says you can infer this from anything, indeed from nothing. Now, within classical logic, both of these things are accepted, okay, and they're going to go hand in hand. But we're going to find, it's take us a little while to get there, that there are circumstances where someone might reject bivalence but keep the law of excluded middle. Now, before we go on, let's just take a second to think about the law of excluded middle, because you might think, going back to how we thought about natural deduction, that we haven't seen this appear before. In fact, we have. It's featured in the exercises, but only as kind of a side feature. Okay, the law of excluded middle is not one of the foundational features of the logic as we have gone through it. But let's just take a second to go to the whiteboard and look at why it is that we know the law of excluded middle is true using natural deduction. Okay, so I want to prove on the basis of no assumptions that P or not P is true, right? I want to demonstrate that it's a theorem, something I can just prove without having to get anything to get me started. So I'm going to do this in the following way. I'm going to assume for indirect proof that it's not the case that P or not P is true. And I'm going to try to get myself a contradiction. So The first thing I might think when I look at this is there's not really much I can do. Okay, so I've just got a negated claim. So what can I do with that? There's nothing I can unpack. I haven't got any rules for what I can do with a single negation. So I'm actually going to have to do a slightly more complicated proof. I'm going to have to go one further. I'm going to have to make an additional assumption. And my additional assumption is going to be not P. So on the basis of not P, I can then conclude P or not P, okay, from the assumption that I've made and disjunction introduction. So if one disjunct is true, the disjunction comes out true. But once I've done that, I immediately say I've got a problem. Right, I've got P or not P on line 3, I've got not P or not P on line 1. So I have myself a contradiction from 1 and 3 contradiction introduction. Now, what can I do if I've managed to get a contradiction from assuming not P? Well, I can conclude P outside the context of that subproof. So from 2 to 4 and indirect proof, I can conclude P, but I'm still in one layer of assumptions. So I've got to do something more. But I can actually just repeat my trick from before. If I've got P, I can get P or not P. So from 5 and disjunction introduction, I can conclude P or not P. But I've now, in the opposite way, gotten myself a contradiction. So from P, I got P or not P, but that, again, is going to be a contradiction. Okay, so from my initial assumption and this new result that I've been able to get, and contradiction introduction, I'm able to conclude this. But I assumed that P or not P was false, and I got myself a contradiction, which means I can finally conclude that P or not P is true from 1 to 7 and indirect proof. Okay, so what I did was I took 2 steps in. I assumed that P was false and found that I would get P or not P as a result of that. That got me a contradiction. So I had to assume that P was true, but that got me a contradiction as well, which then allowed me to show that I had to give up my initial assumption, my assumption that it was not the case that P or not P, and I get my result. Great. So this shows us that P or not P can be proven on the basis of no assumptions. It's therefore a theorem within our system, within our original classical system. So even though it wasn't one of the rules that we made use of, it's still something that forms an integral part of what we've got. And we're going to have to give up some of the things in our system if we wanted to get rid of this. Now, why would we want to get rid of one of these principles, bivalence or law of excluded middle? Right, we're going to focus a bit on bivalence, and then we're going to see how some things about the law of excluded middle fall out later. Now, bivalence is intuitively appealing to us because it seems like those are the 2 possibilities, right? True and false seem to be the 2 options. It keeps things simple, and it seems to make sense of how we talk about the world, how we see the world. But there are 2 broad reasons we might give for rejecting it. So one thing we might say, one option is to insist that there are some well-formed sentences that cannot be assigned either of the 2 values. Okay, they are truth valueless. Okay, it would be inappropriate to assign them either the value true or the value false. We simply shouldn't accept doing that. Now, we do that for certain things we might think of as sentences, right? If there's a nonsense sentence, we might not want to assign it a truth value. But we might say that a nonsense sentence is not actually well formed. The idea here is that there are some sentences that are completely fine in their own right and are expressing something, but then nevertheless we cannot assign either the value true or the value false to. Another option is to insist that we need more than 2 truth values, and to say that there are some well-formed sentences that should be assigned a 3rd value. Okay, this again can seem quite strange to some people, but the thought is that maybe truth and falsity don't actually exhaust the kinds of things that we can describe within the world. Now, just a quick note here, we might ask, is there any difference between these two claims? We may well think that the first of these claims is actually just a misleading way of stating that some sentences have a third truth value, which we can call neither true nor false. Okay, so if we say they are truth valueless, we might ask, well, what is their status? And if we get told they're neither true nor false, it looks like that is the truth value we want to assign them. So we're going to focus on systems that talk about there being a third truth value, while being aware that we might take this slightly different perspective, because it's somewhat clearer for us to actually reason using a third truth value than to try to express the alternative kind of claim. Now, there are a lot of different reasons people have put forward to pursue logics with more than two truth values, but let's just quickly recap several examples of cases where people have suggested we do need more than this, or we need to actually revise this principle. Later, we're going to look in a bit more detail at two of them. So here's one case, incompleteness. This occurs when we think about fictions quite often, but we can actually ask questions about what things are true in a fiction. But here's a special feature of fictions. Okay, so for those of you who are familiar with Game of Thrones, we've got a character called Sansa Stark, and at least as far as I remember, it is not established by the fiction of Game of Thrones that the sentence Sansa Stark is right-handed is true within that fiction. So we might say, okay, well, Sansa Stark is right-handed is false. But what follows if, in ordinary cases, if it's false that someone is right-handed? Well, it seems that it follows that either they're left-handed or they're ambidextrous. But Sansa Stark is left-handed and Sansa Stark is ambidextrous are not established by Game of Thrones either. So we look like we've got a situation where all three of these things are false. But that seems just confusing. Okay, how could it be false that she's right-handed, that she's left-handed, and that she's ambidextrous? That seems to exhaust all of the possibilities. So rather than trying to express the idea that they are all false at the same time, we might say that these statements, things that are not decided by a fiction, are indeterminate. Here's another option that was a while ago quite popular, but actually it's a far more complex debate than we have the time to go into here. So we can think about quantum mechanics. So the uncertainty principle tells us that it's impossible to measure a particle's position and momentum simultaneously. Okay? It's not possible to do both of those things together. So a sentence like particle A has position P and momentum M looks like it is unknowable. It's something that we cannot measure. There's no way of us finding out about. But someone might say, perhaps it's not just unknowable, it's indeterminate. And you'll see lots of discussion, often done at quite a loose level, of whether talking about quantum mechanics requires us to think that certain things are indeterminate. Really interesting area, but it's something that to talk about properly, you really need to understand the nature of the science that's being spoken about. Another example, consider the sentence, this sentence is false. Okay, this is known as the liar sentence, or it's one version of the liar. If we treat that sentence as true or as false, we get to a contradiction. Okay, if it's true, then what it says must be true, but what it says is that it's false, therefore it's false. Or if we assume that it's false, then what it says is false, but since what it says is that it's false, it must then therefore be true. So people have thought that we need a third truth value in order to describe paradoxical sentences like this, in order to be able to represent them in the right way. We might say it's neither true nor false, or it's both true and false, or something else entirely. It's very hard to say what exactly we should do about the sentence, but that is one of the things that we can suggest as a way of trying to deal with the liar paradox. Now, the last two we're going to explore in a little bit more detail in the next video, but just briefly, we have vagueness. So Dwayne "The Rock" Johnson is bald. Please remember that his full name is Dwayne "The Rock" Johnson. Now that he's in movies, people seem to be forgetting the middle name, but I feel like that's the most important part. Anyway, he's bald. Boris Johnson is not. But what should we say about borderline cases, right? There is a spectrum of people from the bald to the non-bald. One thought is that for the area at the edge of a vague concept, we should have a third truth value. Finally, statements about the future. There are statements about what has not yet happened, but which might happen. And there's a worry, a long-standing worry, that if we say that they're true now, that means that the future is fixed rather than open. So we might feel that we need to say that they are indeterminate at the moment. And we're going to think about these last two questions in the next video.